In today's video, we're going to look at connecting up the electron diffraction tube. The diffraction tube is a Teltron tube, so it's an evacuated glass bulb. It has a white phosphorus screen on the end, and it has a cathode and an anode. I've actually got the inside bits of a broken one. So the cathode has a heater and it emits cathode rays, and these are pulled towards the anode. The anode is connected through that bit, and in the middle of the anode, a little small circle there, is a very thin film of graphite. It's only a 1 or 2 atoms thick, this few atoms thick, this sheet of graphite. And the idea is that the beam of electrons get accelerated towards it and pass through the graphite, and the lines of the graphite atoms act as a diffraction grating, just as a grating would for light, with a certain number of lines per millimetre. So let's look at connecting it. First of all, we need connections to the heater. I'm using yellow leads, and it's a 6-volt supply from our EHT supply, and those go to the 4mm sockets. On most of these tubes, the high voltage cathode connection is a 2mm plug. Oddly, it's marked red on this one, and this goes to the negative of the extra high tension supply, which is then connected to earth. Let's take you in to see that a little bit clearer. So the black lead is the cathode, which is connected to the minus and the earth. The anode, which I'm going to use red leads for, I'm using shrouded leads on these high tension ones. They're retractable shrouds for our old bit of kit. This prevents us touching it accidentally. So I've connected to the positive side, and I'm going to go into the amp sockets of a multimeter, which I've got on milliamps. I've got it on a 2 milliamp maximum, and from the multimeter to this side connection, which is this connection that connects to the anode with the graphite film in it. So I'll pause briefly to turn the lights off, pull some blinds down, and turn the tube so that you can see the end of it. Some diagrams show a optional 50 volts to help focus the beam, which goes between one of the heater terminals and the cathode. This just should give you a finer beam in the middle and slightly sharper rings. So to do the practical, we turn on the power supply with it down at 0 and look in there for a little glowing cathode. I'm actually going to take that bit off, so you should be able to see the cathode glowing, and when that is glowing we can start turning the voltage up. Keeping an eye on the ammeter, I'm going to go slightly higher than it says of 0.2 milliamps because ours seems to need a little bit more current. So about this level we're starting to get a glow on the screen as well as the dot. And if we increase the voltage gradually, we should start to see some rings appear. Now they don't seem to show up particularly well on the camera, but I can see light and dark rings, lighter ring here and here with darker bits in between. So the camera doesn't quite pick those up as well as they are in real life. Now the modern tubes are supplied with a little magnet on a clip. Putting this on the neck of the tube shows that the dot will move so that it is a charged beam of electrons, and supposedly if you burn a hole through the graphite this will move the ray to a slightly different part of the graphite, so you can still use the tube if the center is perforated.